Okay, so this question is looking at the different structures of benzene and comparing the Kekulé model, as you can see here, with the more up-to-date delocalized model. So questions about benzene structure are common on these exams, so you need to make sure you fully understand basically what Kekulé structure is all about. You can remember and recall the evidence against his structure, and then just be able to describe and draw diagrams that outline the delocalized model. So this question is asking you to compare the structure of the two. So assuming Kekulé's structure was correct, what the bonding would look like in this molecule if this was the true structure of benzene, comparing it to the delocalized model. So describe with the aid of suitable diagrams showing orbital overlap the difference in a bonding between structure A and structure B. So we'll start with Kekulé's benzene. So if Kekulé was correct, his theory was we had this alternate system of double and single bonds. So if Kekulé was correct, that would mean there would be 3 areas of localized electron density. There'd be 3 pi bonds like you'd find in an alkene. So Kekulé's structure, if we say structure A, if it was correct, if we were to draw the hexagon as you see it, would indicate there would be 3 areas of localized pi bonds where the double bonds are. Okay, whereas structure B, we're looking at the delocalized model. Draw a hexagon here. What we've got with structure B is, remember, it's to do with the overlap of the p orbitals. So if you imagine your p orbitals on each carbon atom, and they are then overlapping to form this system of pi bonds above and below the plane of the ring. These are your p orbitals. And what we can say is the p orbitals overlap to produce a pi bond above and below the ring. Okay, whereas in Kekulé's structure we'd have 3 areas of localized electrons, whereas in this one we've got delocalized electrons. All right. Whenever you're doing answering any questions relating to diagrams of the benzene structure, it's always wise to label everything. Make sure it's nice and clear what all your diagrams mean. Okay. So if you without the label of the pi bond here, this hexagon and semicircles just looks meaningless. All right. And similarly, make sure you're labeling your p orbitals on your benzene structure and indicating what's happening. So stating the p orbitals are overlapping. Okay, so it's an odd question, this one, in the sense that you're having to explain a structure that isn't really strictly true. So there we go, that's a suitable answer for that question.